Hello. In this lesson, we are looking at kinematics, which is a topic to do with motion of a body or indeed systems of bodies. And we won't be dealing with the forces, so the causes and effects and things like that. We'll just be looking at displacement, velocity, and acceleration. And we'll have different questions on trigonometry or exponential functions and so on. On screen, you can see me writing down SVA. So that's displacement, velocity, and acceleration. And in that direction, you'll be differentiating. So we're given a displacement of a particle given by that function there with 6 cosine. And we have to find the acceleration. So we're going from SV to A. So what we're going to do, of course, is we're going to find the derivative of 6 cosine bracket 3t plus pi over 3, close bracket. The inside part will stay the same. So dx over dt, and now d squared x over dt squared. We're doing this with respect to time. So think of it like generally with these questions, we have constant acceleration. So you'll have velocity and time graphs, let's say, and you're always doing it with respect to time. Same with a distance time graph or displacement. So find it when t is equal to 2 pi over 3. We'll just substitute that in now after we've found that second derivative. So minus 54 cosine, 3 times 2 pi over 3. So 6 pi plus pi is 7 pi. And now we'll simplify that, or we'll just finalize our answer. So the acceleration is minus 54 cosine 7 pi over 3. And you can get your calculator out and find that answer. So minus 27 meters per second. Okay. Next question. A particle is moving in a straight line. Okay, the acceleration is given, minus 6. When t is equal to 0, we have a velocity of 18. So take note of those aspects. They'll be dealt with properly in a moment, but separately too. So we define a time in which p comes to instantaneous rest. So think about it. At rest, it means that it has stopped moving. So velocity will equal 0. And it's linear, so we'll just make sure that it has a linear equation. Velocity is minus 6t plus 18. Again, you could draw a graph if you want. Think about what these things are. Like c is 18. 18 is our initial velocity, but it's also where it crosses the y-axis, the y-intercept. I've drawn that picture as a general idea, but of course you can see it as a negative gradient on this particular example. But that's how it would look when you're doing constant acceleration, when you're doing certain questions with graphs. So just to give you your bearings with that, the acceleration, of course, is a slope, is a gradient, like the minus 6 that you see in that equation. Okay, so just keep that in your head. I'm going to put in the gradient, but it doesn't matter. So v is equal to minus 6t plus 18 is our linear equation of that. And find the time is where v is equal to 0. So just plug in or substitute that. So, excuse me, minus 6t plus 18 will be equal to 0. And of course, t is equal to 3. So t is equal to 3 seconds. When you get 6t is equal to 18, divide 6 on both sides, you get t is equal to 3. The second part, we have to find a distance traveled in the third second. So between the second and the third second, and just going back over our SVA, so displacement, velocity, acceleration, we're going from velocity to displacement, which means we integrate. So that mnemonic that you saw in the previous question and here in the green there, that's something that we use for this over and over. So write it down. If you're, if you're sure of it, that's great too, but always write it down just to have it there as a visual mnemonic. We've just integrated that there, so between 3 and 2, sub in your limits. So minus 3 times 3 squared plus 18 times 3, all in the bracket. Subtract minus 2 squared plus 18 times 2. And that's how you integrate. So the distance traveled is 27 minus 24 meters, which of course is 3 meters. And that's how far it traveled in the third second. Our next question now, you'll notice that they're getting quite similar. You're just using different functions. The acceleration in this straight line is given. Function when t equals 0, the velocity is 10. This is almost exactly like the last question. In a general sense, a different function obviously. So we're going from a to v. So that's integral. So v is equal to 3. So 6 over 2 is 3. 3 sine 2t. Just remember that cosine is equal to sine. Plus c, of course. When t is equal to 0, v is equal to 10 meters per second. So again, you're usually just substituting in these ideas. Let me fix that. 0 there. So c is equal to, well, 10, I suppose. That's straightforward enough. So the velocity statement is 3 sine 2t plus 10. Okay, next, find the displacement. So we're going up again. Another integral. So s is equal to, again using the velocity here, 3 sine 2t plus 10 with dt, so with respect to time. I put in dt, let me just move that. 2t. 2t. Okay, that's straightforward, I think. Yep. So equals minus cosine, so minus 3 over 2 cosine 2t plus 10t plus another variable, another constant, we'll just call it d. Next in line, plugging in our numbers, so v is equal to, well, t is equal to 0, so we have s here, sorry, give me a second here. So yeah. So minus 3 over 2 cosine 2t, and t is 0, so put in plus 10 times 0 is equal to d, so strange enough, you're just going to get 3 over 2, I presume, here, so 3 over 2 goes across the equal sign. So d was equal to 3 over 2. We can rewrite now our full equation, or function. So minus 3 over 2 cosine 2t plus 10t plus 3 over 2. And that's the final answer for that. We found a displacement of q from the origin at that time. So far, you can see the trends. There's kind of a similarity between these questions, as you notice in a lot of maths topics anyway. You're starting to see that, there's a certain expectation and conventions, as I say, with notation. Again, we have a straight line here, which is 10 sine 2t minus 5. Find the speed, so speed being velocity. So we're using differentiation here, and then eventually we have to find the acceleration. Displacement is 10 sine 2t minus 5. So, first question, when t is equal to pi, we'll be substituting that in at some point. So dy, now dx over dt is equal to 2 times 20 cosine 2t. And then from there we can substitute in our t, which is pi. And so 2 pi, yeah, straightforward, this is 20. 2 pi is 1. So the cosine graph, if you think about it, when it goes through the start, the origin, or 2 pi itself, which is one periodic pattern, it goes through 1. So 20 times 1 is 20 meters per second for the velocity. Part 2, plugging in those aspects again for s equals 0, and at rest means velocity is equal to 0. And just rearrange that then. So t is equal to pi over 4, and from there we can find our acceleration and something else as well. So acceleration, again, we'll just do the same thing. We're putting the derivative as we go on, from displacement to velocity to acceleration. So 20 cosine 2t. We'll be using that t, I believe. It doesn't have the word hence, but if you ever see the word hence, H-E-N-C-E, it always indicates we're using something from a previous part of the question. So there we've done that. 2 times 20 is 40, of course, and cosine is equal to minus sine. That's your derivative, and then plug in t is equal to pi over 4. So minus 40 sine 2 times pi over 4, which is a nice and handy answer. Again, minus 40 meters per second. Your calculator will do that work for you at the end there. Now we're on question 5. We've got 2 more. This one's a little bit more expansive, and the last question is to do with exponentials. So again, the same details, which might give you some hope, might give you some confidence when you start doing a lot of questions. If you start to see patterns and trends and connections, I mean, that's the whole point of maths, really, that you can start to see things. And of course, your investigative skills will improve too. If you have to find out things like integrals, for instance, you have to search maybe the technique for integrals later on in your maths career. 2t plus 1 to the power of a minus a half, and find the integral of that. I'm using the chain rule here as well, be careful. So plus 1 is a half underneath, and also times by a half, plus c. So of course the halves can cancel out. 2t plus 1 to the power of a half plus c. Find the velocity. Okay. We're going to have to find our c as well, so we'll plug in what we have. We were given t is equal to 0. Particles 4 meters, we don't need that yet, and we have a velocity of 8 meters per second, which we're doing there, where t was equal to 0. So obviously the particle being 4 meters from the fixed point or origin will be needed soon enough, I expect. In the second part, so finding the displacement next of the particle from the origin at time t seconds. So you can probably guess at this stage, if you knew already, and that's good too. We're doing our mnemonic SVA and we're going upwards. So acceleration to velocity to now displacement. So 3 over 2 over 3 over 2, adding 1 each time, n plus 1, and we've the same thing there. So the inside part is a half, and plus the 7t, 7 the letter t, and plus another constant, we call that d. S is equal to 1/3 bracket 2t plus 1 to the power of 3 over 2 plus 7t plus d. We can find d as well. For that part there you saw, which 2t plus 1 all over 3 over 2 times the inside part, so the chain rule being activated there. Just do that stuff in your calculator if you're having trouble, but you should work in isolation with these kind of things. There's kind of little shortcuts and things when you're doing that. So just check it out, and especially we're working with exponents as well. So we had that particle, it was 4 meters away from the fixed point. So you plug that in, t is equal to 0, so it should be straightforward. 4 minus the third is 11 over 3. S is equal to, rewrite this all out, 1/3 bracket 2t plus 1 close bracket 3 over 2 as an exponent plus 7t plus 11 over 3. So that was our displacement of the particle. Last question. The particle moves in a straight line. Okay, we're getting used to this now. Past a fixed point, and we have a displacement, and our function is exponential. Excuse me. Exponential. So find expressions of velocity and acceleration. Basically just go and do what you've been doing, but remember the rules of exponentials, which aren't too difficult, to be honest. You might have, as we say here, we have e to the 2t, and the derivative of the exponent, 2t, is 2, so plug that out front. So 2e to the power of 2t, and the rest of it is straightforward there. What you've done prior in any of these. The acceleration was fine too, same thing. So 2 times 2 is 4 to e to the 2t minus 10e to the t. So when the particle is at rest, we'll equal it to 0. Now there's a little bit of a idea here. We have to do a substitution. We have to do something to make this easier to calculate. And a nice way to do that is to find, like, e to the t is equal to y in this case, because we have a quadratic. So once you've done that, you get y is equal to 6 and y is equal to minus 1, which means e to the t is equal to 6 and e to the t is equal to minus 1. We can straight away take away that minus 1. It has no solutions. And when y is equal to 6, we have e to the t is equal to 6, so t is equal to ln 6, the natural logarithm there, which is the inverse of the exponential function. Now that we find that, I'm sure this goes into our next question, when we have t, acceleration of this, so just think about the mnemonic we had. So 4e to the 2t minus 10 et was our acceleration. We did that in the first part, and we replaced t with our ln 6. So there's really not much more to this question. You can use your calculator for this part as well. So a is equal to 84 meters per second, and that's the acceleration at that time. And that's 6 questions on this. I didn't do any graphs, we just did algebraic and calculus-based work. And to think of that mnemonic on the top right-hand corner as well when you're doing this. Kinematics. And you'll also become familiar with constant acceleration as well, which is a separate topic, which will involve more of the graphs.